Hi everyone, this is Miss Glazer, and I'm going to walk you through the literal equations notes. So this hopefully is review. They taught you literal equations in Algebra 1. They reviewed it again in Algebra 2, and we're just reviewing it again because this little paragraph here, the issue is sometimes you have a formula and you want to solve for some other variable other than the standard one. So they gave you, for example, the perimeter formula. Maybe you want to solve the equation for S instead of it being solved for P. And so the process for solving the formula is called solving a literal equations. One of the definitions of literal equations is related to or being comprised of letters. The variables are sometimes referred to as the literals. So another way of saying solving literal equations is we're taking an equation with lots of letters and solving for one letter in particular. So in example 1, we want to solve this equation for b. To get b by itself, we just divide by 2. And now we have that b equals 3/2. Wasn't that easy? So the next one, we're also solving for b. Well, it's very similar to example 1. Now it's an h. To get b by itself, we're going to divide by h, since currently b and h are being multiplied. And so we get b equals big A over little h. If hopefully you noticed, this equation was the equation for the area of a parallelogram. In the next one, moving right along, we're solving for r. Well, the equation is d equals r times t. So to get r by itself, we're going to divide by t. And we get r equals d divided by t. And this is the distance equals rate times time formula that you probably use a lot in science. And so if you wanted to figure out what the actual rate was, it's just the distance divided by the time. In example 4, we're taking the perimeter of a rectangle, and we want to solve for the length. So just like we're solving regular equations, I don't want to touch the term with the L in it first. I want to just get rid of the other term. So I'm going to subtract the 2w first and get 2L by itself, and then divide by the 2 to get L by itself. So you can leave your answer as L equals P minus, make that big P, minus 2W all over 2. Or if you like to rewrite it as P over 2 minus 2W over 2, and then simplify this one right here, you could rewrite it as P over 2 minus W. But with literal equations, we're trying to just get the variable isolated. So this one would be perfectly acceptable, or you could use this way. We would accept either answer. In number 5, we're trying to solve this equation for D. Sometimes our equations that we're solving for aren't equations that are like actual formulas. This is potentially a formula from science. I don't recognize it, but the point is we're trying to get D by itself. So I have Q equals C plus D all over 2. So the first thing I need to do is multiply both sides by the 2 to get rid of the denominator. So I'm going to get 2Q equals C plus D. And then I'm still trying to get D by itself, so I'm going to just subtract C from both sides. And so I get 2 times big Q minus C equals D. So you just want to keep looking for that letter that we're trying to isolate. In example 6, we're trying to solve for T. T is in the denominator this time. And so the first thing that I would actually do is multiply by T. Now that seems kind of silly because we're trying to solve for it, but I need to get it out of the denominator first. So I'm going to have VT equals 3K. Now that it's out of the denominator, I can divide both sides by my V, and T will be isolated. in example 7. This one is one that always causes people trouble. So we're trying to solve for A, but if we look, A is in both terms. And so hopefully we realize when we have a variable in both terms, we can factor that variable out. So I'm going to factor out an A, and what's left after I factor it out or divide it out of each term, I'm going to put A in front, 3 plus 5C will be left over. And now, because I want to get A by itself, this is just being multiplied. So I'm going to divide by the whole sum of 3 plus 5C. And so we get A equals big Q divided by 3 plus 5C. Example 8, we are trying to solve for H. Again, H happens to be in both terms. So the first thing that I would do, so actually there's two different ways you can approach this one. And so I'll show it to you both ways. So the first thing we can do actually is multiply everything through by 2 to clear out the fraction first. But if I multiply everything on this side by 2, and this is multiply, not raised, multiply by 2. If I multiply everything on this side by 2, I have to multiply everything by this side on 2. So I'm going to get 2A equals AH minus BH. Now, using that same strategy from example 7, because I have an H in both terms, I'm going to factor the H out and have A minus B left in parentheses, and then just divide by A minus B. And so my final answer is that H equals 2 big A over A minus B. Now, the other way you could have done this one, so I'll just rewrite it. You could take out the H first and bring that out front and get 1/2 A minus 1/2 B. And then just divide by 1/2 A minus 1/2 B. Technically, I'm not going to have enough room to make it fit. Technically, this would be perfectly acceptable as well, because like the directions are just saying to isolate H and get H by itself. This first one right here that I'm starring is just a little cleaner, and doesn't have fractions within a fraction. So typically we like to avoid fractions within a fraction, but either would be acceptable. Last example. So we're solving for S. S is in our numerator. And so this one's going to work out fairly nicely. We're going to multiply both sides by the 360. And so we get 360A equals pi r squared S. Pi r squared S, these are all just being multiplied together. So I'm just going to divide by pi r squared. And I end up with S equals 360 big A all over pi r squared. Now, you'll notice the next page is your practice. So I'm going to just notice you want to solve for the variable in the parentheses. So in number 1, you're solving for the t. So for example, I would just divide by big I, big R, big I, big R. And so I'm going to get t equals p over big I, big R. And so just make sure you're solving for the variable that's indicated. So number 2 is W, X, Y, X, B. Like just make sure you're solving for the variable that's indicated. I'm going to skip over, jump down, and problem number 21. This is a review of your limits. I'm going to just review G, H, I, and J. It's important to remember that the little little plus sign after the -6 is telling us to come from the right-hand side. And so if we look at our graph, here is -6, like this is where -6 is on our graph. And so if we're coming from the right hand, approaching from the right, it's going to be at the value of 5. And when we're approaching -6 from the left, which is what this little negative is telling us, it's going to be at, that's a little off, but it's at +3. And so because our limit as we approach from the right and we approach from the left are not the same, then the limit for as x just approaches -6 does not exist, because they're not the same coming from the left and the right. And just to remind you also, the function when we evaluate for the value of x equals -6 isn't always going to be the same as our limit. So right here, when we actually are at the function for -6, that is when the value equals y. So when the y value equals 5. So the function when we substitute in -6 is the same as the limit for when we were approaching it from the right-hand side, but it's not the same as just in general. So just to review that for you. Number 22 and 23 are pretty challenging. So these are kind of like some challenge limit problems. The trick with the first one, I'm just going to get it started for you to remind you, and you can check the key as well. You're going to want to multiply both the top and bottom by 3 plus the square root of x plus 5. And when you clean that up, what's going to happen is you're really going to end up with being able to cancel out. So 22 is definitely a challenge problem, but check the key, see if you can figure it out. I don't want to give you much more. Like if you can do 22 on your own, then you're really understanding the math. You're doing good for pre-calculus, and you're on the right track if you're planning on doing AP Calc next year. And in number 23, my hint to you is x minus 27 is the same thing as x to the 1/3 raised to the 3rd power minus 3 to the 3rd power. And so this is difference of cubes. So if you were to rewrite this top one, it would be x to the 1/3 minus 3 times x to the 2/3 plus 3x to the 1/3 plus 9. And that's going to be all over x to the 1/3 minus 3. And so now the nice thing is these are going to cancel, and then the problem becomes a lot simpler to solve. So that was the challenge with this one, realizing you had to rewrite x minus 27 in terms of difference of cubes. So see what you can do with that practice. Hope everyone is doing well and enjoying the nice spring weather that we're having most days.